agricultural revolution happened during the Neolithical era when man moved from hunting and gathering to organized farming. Ever since then, agriculture has come a long way for humankind and is one of the key economic factors in a lot of developing and underdeveloped nations. Join me in the next 1 hour to understand how the Internet of Things can be combined with modern technology and a new technology known as smart farming or intelligent agriculture is born. Intelligent agriculture can provide food security all over the world, ensuring quality of the yield, ensuring quantity of the yield, and providing mankind with unprecedented convenience. Traditional agriculture can be divided into plantation and livestock monitoring. There are many challenges that come with traditional farming. For example, traditional farming can be extremely labor-intensive. Horizontal planting is space-consuming. The traditional methods waste a lot of water and fertilizer, most of which is absorbed by the land and not by the roots of the plants. The crops and the livestock are exposed to extreme weather and pests. The weather cannot be controlled, therefore not allowing us to have guaranteed yields and production, and the inability to control the quality of the crops and livestock produced. Agriculture can be divided into two parts, the fertigation system and the hydroponic system. In today's world, the pictures here show an example of aquaponics is a type of hydroponic systems which is combined with aquaculture. The waste from the fish is used to supply nutrition to the plants in the hydroponic system. Aquaponic systems use a special type of filter known as biofilters, which are made from porous material such as gravel, clay pebbles, and other biofilter media, which provide a large surface for beneficial bacteria to colonize. These bacteria, which are the Nitrosomonas bacteria and the Nitrobacter bacteria, are used to convert ammonia from the fish waste into nitrites and nitrates, which can then be easily absorbed by the plants as fertilizer. The biofilter also works as a water clarification system to remove suspended solids and improve water clarity, thus allowing the fish to grow healthily. Aeroponics is an upcoming type of hydroponic system where the root of the plant is not submerged in water all the time. Instead, water and nutrition is supplied through a time-based spray or a mist of nutrient solution. While aeroponics saves a lot of water, it is not yet a popular technology in many parts of the world because it is quite an expensive system to implement. Fermentation systems do not use water as a medium. Instead, they use alternative media like leca balls and cocoa peat. Fertigation systems are often found outdoors, within a structure known as the greenhouse. The greenhouse provides some extent of protection against pests and at the same time provides climate control for the plants from extreme outdoor weather. Tanks inside the greenhouse are used to mix the fertilizer, which is then distributed to the individual polyphylla bags using a drip irrigation system. Now we will take a look at the role of technology in modern agriculture. So far, modern agriculture has seen the use of automation, but the integration of IoT will allow specific features such as remote monitoring and remote control, which cannot be achieved by automation alone. Smart farming, or a subset of smart farming known as precision agriculture, uses advanced technologies and data analytics to optimize agricultural practices. The technology that is often used is Internet of Things, sensors, robotic systems, machine learning, artificial intelligence, drones, and geospatial analysis. Geospatial analysis is when information on the specific location of a pest or a specific location where water is lesser as compared to another larger area is provided inside the IoT system, and the farmer is able to monitor this and take action accordingly from afar. He does not have to go to the field to take action. The intention of integrating modern technology into modern agriculture is to enhance productivity, efficiency, and to ensure sustainability in agriculture, reduce water and soil wastage, and to adapt to weather and environmental conditions. By this way, in a large scale, we can ensure global food demand met for a growing world population. and ensure that the food that is sent out to everyone is of good quality and as free from pesticide as possible. An IoT technology is essentially a network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. An example of an IoT system would be a smart air condition. The smart air condition system can be given a threshold temperature. Let us say this threshold is now 24 degrees Celsius. When the temperature drops to 23 degrees Celsius, the sensor will detect this drop in temperature and inform the microcontroller. The microcontroller will then take an action because it has been programmed to ensure the room temperature is always 24 degrees Celsius. This way, it will interact with the internal electronics of the air conditioning and instruct it to go back up 1 degree Celsius so that the room temperature is maintained at 24 degrees Celsius. The system is typically made out of three main parts: the microcontroller, the cloud platform, and a smartphone application. Now the microcontroller is connected to the sensor. Data is collected from the sensor and sent for processing to the microcontroller. The microcontroller will then make a decision based on the program that is written on the microcontroller. Once a decision has been made, the microcontroller will instruct the actuator to take action on a certain condition or situation. All the information that is collected by the sensor can be sent to a cloud platform. A cloud platform is typically the internet, and the data that is saved on the internet can be used for remote monitoring or remote control of your IoT system. If the IoT system is used to control a smart farm, say, and you want to turn the pump on due to extreme hot weather, then the farmer can actually turn the pump on using the cloud platform because the information of the current temperature on the farm is available on the internet for him to view from his home. Now, ideally, all internet applications should have a smartphone application. However, many systems monitor their IoT systems from a dashboard which is available on your PC. The typical building block of an IoT system consists of sensors, connectivity, actuators, and processors. Let us take a look at what are the functions of these building blocks. Sensors play a role in detecting the quantities that surround us, for example, temperature, moisture, or pH levels. These sensor readings are then taken by the microcontroller and interpreted, and a suitable action is taken by the actuator. Connectivity using 4G or 5G technology or even Wi-Fi technology is the backbone of the IoT system. Without connectivity, information from the local sensors gathered from a local environment or a local equipment cannot be sent to the internet. Without the information being displayed on the internet, the owner of the IoT system cannot remotely monitor the parameters that he wishes to monitor. It will also disallow him to do any remote controlling of the IoT system from afar. The microcontroller is the brain of the IoT system. It makes decisions based on data collected by the sensor and instructs the actuator on how to react to a certain situation. Most embedded controllers have limited memory and computation power. However, they can be easily programmed using assembly language and are cheap. They are also energy efficient. Examples of the microcontroller is the Arduino and the ESP32. What is an actuator? An actuator is a component that actually does the action that you want it to do. So after receiving the instruction from the microcontroller, the actuator will react, for example, to control the temperature or to turn on the motor or to turn off the motor or to increase temperature. The IoT system needs to be programmed in order for it to achieve the goals of its application. Programming of the IoT system can be done using simple languages such as Scratch, Java, or even Python. Let's talk about how IoT systems with their sensors and their microcontrollers can be integrated into agriculture to overcome the challenges of traditional agriculture. With the IoT system, more automation can be achieved with specific features of remote control and remote monitoring. Resources can be used efficiently and waste can be reduced. Extreme weather can be controlled through the use of certain physical devices such as the fan and air conditioning, and also an automatic water sprinkling system which will reduce the surround temperature and encourage more healthy growth of the plants. Sometimes the plants that you grow are not healthy in spite of you giving it the required fertilizer level and water levels. This is because the soil is probably too acidic or too alkali in nature. Thus, when the pH level is monitored, suitable action can be taken from near or from afar through the use of the internet to control the pH system. Lastly, advanced systems are beginning to use imaging systems to identify and quantify the amount of pests that are existing in the farms, and this enables the quality of the crops to be increased. In fact, even for livestock monitoring, sometimes pests can cause disease and death in livestock. Therefore, the pest control system can also be applied in livestock monitoring. This picture here shows us how the smart farming system can use an IoT system. Sensors inside the soil can detect the soil acidity or the soil salinity and also the soil moisture. And this information is sent to a sensor node. Via the use of the antenna, the sensor node will send the information to the cloud for processing and for further action by the actuators. IoT-based smart farming can use a simple system such as a moisture sensor, and the moisture level is sent to the Arduino board, which is the microprocessor, and the microprocessor will do a decision whether the moisture level is acceptable or the actuator, which is the sprinkler system, needs to turn on the water. Let us now see how sensors and gateways cooperate in a smart farm. The sensors detect relevant data such as moisture and temperature and transmits this data to the ESP32 microcontroller. Note that the input pins of the ESP32 should be programmed accordingly. The ESP32 then uses its communication module to push data received from the sensors to the cloud. Data from the cloud can be displayed on platforms such as the Blynk. Blynk platforms use virtual ports that can be configured to display data received from the ESP32 communication module. For example, the dashboard created here has been configured to display temperature, humidity, moisture that is received from the ESP32. At the same time, the Blynk dashboard here has been configured for remote control of turning on or turning off of the water pump. The actuator can be programmed to respond based on sensor threshold or can also be remotely controlled from the dashboard. IoT systems in livestock monitoring will enable the farmer to detect vital signs of the animal or to know exactly where the animal is at a given time using the global positioning system. Now, don't you think this is going to help the farmer very much because he does not have to go to the farm every day?
can build your own NFT system at home. Simply buy an NFT system over the counter, buy an aeration stone, buy an EC meter, and buy suitable solutions to provide nutrition to your plants. After you have set up your own smart farm at home, let us now see how we can incorporate some IoT into your system at home.
You can build your own IoT system at home. The first thing to do is to identify the objective of your IoT system. After you identify the objective of your IoT system, you can design your IoT system. Then you may purchase suitable components. For example, if you want to build an IoT system to control a smart farm, then you may purchase components such as sensors, cables, and microcontroller. You can try using an ESP32 microcontroller. Assemble the components and then automate the sensors by programming the ESP32 microcontroller. You can program the ESP32 microcontroller by using Scratch IDE. Now you have to build your own dashboard. I would suggest that you use Blynk.io. Finally, the dashboard is ready for you to remote control and remote monitor your IoT-based smart farm. The picture here shows a suggested assembly for the monitoring of soil moisture and also ambient temperature and surround humidity using the DHT11 sensor. You can customize your own Blynk dashboard. To start, you should set up a Blynk account. Download the Blynk app, create an account, and log in. Now, to create a new project, you need to open the Blynk app and tap on New Project. Choose a project name, example Smart Farm. Select the microcontroller that you are using and the connection type. Tap Create. You will receive an authentication token via emails. Keep this carefully. Now you need to connect the hardware. After connecting the hardware, install the Blynk library in your development environment like Arduino IDE. Use the authentication token in your code to connect the hardware to the Blynk server. Add widgets to the dashboard like value display, button or slider to display the various values which are captured by your sensors. Configure each widget by defining a virtual pin for each sensor actuator. Use Blynk functions to read and write data to these virtual pins. Customizing the Blynk dashboard is a really fun activity, and you should try it out.
Both smart farming and the Internet of Things are technologies that are here to stay. There will come a time when a large part of the agricultural sector will be reliant on the IoT for remote control and remote monitoring. If you are aspiring to become an electronics engineer or somebody with a career in IT, then the IoT skill set is a very critical skill set for you to develop and learn. There is no better way to learn something than to experience it hands-on. Maybe you can try the experiments that I suggested in the workshop today. Do let me know how it turns out, and I wish you all the best.